Hello and welcome to this online lecture about hybridization. In chemistry, we sometimes see atoms bonding in ways that we can't normally account for, forming more bonds than they should be able to and such. And eventually, over time, chemists have come up with a theory called hybridization to account for that behavior. So by the end of this lecture, you should be able to predict when an atom is going to form hybrid orbitals and how many hybrid orbitals that atom will form. So let's get started. I'm going to start with the classic example for hybridization, and that's carbon. Now, if you haven't done the electron cloud advanced lecture and quiz, you might want to go check that one out before this one, or you might be a little bit confused. Otherwise, you might want to just brush up on or watch part of that lecture so you can kind of understand what I'm about to say here. But if you look at carbon and you think about how many electrons it has 2 electrons in one s, and then it has 2 electrons in 2s, and that's 4 electrons. And then in 2p, it just has 2 more electrons. And so what we see in carbon is we see that it has one 2p orbital that's half full, another 2p orbital that's half full, and then a 2p orbital that's completely empty. But that doesn't really explain the way that carbon behaves, because when carbon bonds with other elements, we know that it very routinely can form 4 bonds, whether they're 4 single bonds or 2 double bonds. Whoops, I was thinking ahead. Or whatever. We know that carbon forms 4 bonds, and with this kind of a notation, we really only be looking at 3 max maybe if it borrows 2 other electrons from another atom. So what chemists finally started to understand was happening here is that orbitals that are similar to each other in energy level actually combine to form new orbitals. So if you think about the electron cloud of carbon, we've got 4 orbitals here. They're all in the 2nd energy level. Those 4 orbitals are pretty darn close together in terms of energy. So what happens is those orbitals actually combine into a new hybrid orbital, which is where the name comes from. So carbon still has its 1s that's full, 2 electrons there. But now instead of having 2s and 2p, it has 4 orbitals that are a combination of the 2s orbital and the 2p orbital. So the name of these hybrid orbitals, because it's 1, 2, there are 1, 2, 3 p orbitals combined with an s orbital, 1s orbital. Because there are 3 p orbitals combined with 1 s orbital, the hybrid orbitals are called sp3. So it's 2 sp3 orbitals. So how many electrons are in those orbitals? Well, if we look at the orbitals that combined and we count the electrons that were in those, there were 1, 2, 3, 4 electrons in those. That means that there has to be 1, 2, 3, 4 electrons in these hybrid orbitals. And so now what we have 4 equal orbitals. They're sp3 orbitals, and there are 4 of them, and each one of them has 1 electron in it and has a space for another electron to share. And so this is how hybridization explains how hydrogen forms 1, 2, 3, 4 bonds. It combines its s and p orbitals to make 1, 2, 3, 4 hybrid orbitals. And because 3 p orbitals combine with an s orbital, these hybrid orbitals are called sp3 orbitals. So that's basically what hybridization is. It's a combination of orbitals that are at similar energy levels to create orbitals at equal orbitals, equal orbitals by combining the 2 different kinds. So as you may be guessing, you're not always going to see sp3 orbitals. Sometimes you'll get different kinds of hybridization. You can have an sp hybrid orbital, and that comes from one s and one p orbital hybridizing. You can have sp2, and that comes from one s and two p let me try that again. Two p orbitals hybridizing, combining, and then of course the one that we just saw up there was sp3, and so that's 1s plus 3p orbitals. So when you have sp, here's the atom, you get two hybrid orbitals, two hybrid sp orbitals coming off from the atom. When it's sp2, then there are three hybrid orbitals at that point. And then when it's sp3, you have four hybrid orbitals that the atom forms. So when can you kind of guess that an atom is going to hybridize? Well, a good hint that an atom might form hybrid orbitals is if it has partially full s or p orbitals on that energy level. So when you're looking at things like atoms like boron, let me scroll down here a little bit. Boron, right? So boron is 2 electrons in 1s, and then it has 2 electrons in 2s, and then it has 1 electron in 2p. And so what you have here is you have an atom that's got a partially filled up p orbital and a fully filled up s orbital. So it has 3 electrons that it wants to put somewhere, right? It's got 3 electrons that are at the same energy level, see right here, and it wants to put them somewhere, but it ends up putting them in these hybrid orbitals of equal energy level. So boron looks like this. It has its 1s and it's got its 2 electrons in it, but then it makes 1, 2, 3 sp2 orbitals, and then it puts its electrons in those 1, 2, 3. So see what it did is it took its s orbital, so that was 1 orbital, and it combined it with 2 of its p orbitals to make 3 sp2 orbitals for its 3 electrons that it has in its s and p orbitals. Another example might be something like magnesium. Magnesium has, we have to go all the way through, so let's just do, it's got all the electrons that are in neon, right? Well, you know what, I'll just go ahead and write it all out. I've got the time, so whoop. You can fast forward it if you want, but so we have 1s and there's 2 in there. Whoops, sorry. And then 2s and there's 2 in there. And then it's got 2p and that's full. And then it's got 3s, and 3s is full. And its p orbital is empty. There's nothing in its p orbital. So the electrons that it has at its highest energy level are already paired in an orbital, so it's difficult for it to form bonds that way. But it can form bonds using those valence electrons if it makes hybrid orbitals. So what it does is it takes those 2 electrons and it combines its s orbital with one of its p orbitals. So instead of having just 3s, it makes 3sp as the hybrid orbitals, and it makes 2 of those. And then it puts 1 of each electron in those. So it takes its 1s orbital, it takes 1 of its p orbitals, and it combines them together, and that creates 2 sp orbitals. And so now the magnesium combined with atoms covalently that way by sharing those electrons. So that's the idea behind hybridization. When you have atoms that have valence shells that aren't full, oftentimes it will hybridize its valence shells to make these hybrid orbitals. So it might take one of its s orbitals and one of its p orbitals, or it might take one of its s orbitals. Oh, sorry about the ring there. I had a little bit of a phone call I had to take. So yeah, so when you have these valence electrons in partially full s and p orbitals, when you don't have the valence shell all filled up, a lot of times what you'll get are these hybrid orbitals forming instead. Now, the time when you stop getting that is when you get at least one electron in every single one of the shells. So the next one would be nitrogen after carbon. Oops, I want black. And so you have one S, and there's two in there, and then you've got 2S, and there's two in there, and then 2P. So now it's 1, 2, 3. And so now you have too many electrons. You can't form enough hybrid orbitals to accommodate all 5 of those electrons, and so you would not get hybridization in this case. So basically what you're looking at is anywhere from 2 to 4 valence electrons you're going to get hybrid orbitals, but above 4 you're not, and below 2 you're not. So that about wraps it up for this online video lecture. Thanks for watching, and as always, if you have any questions, feel free to ask in class.